Welcome back to Archean. This is episode 6 of the Cargo Challenge. In the previous episode, I made an attempt to make a quote-unquote sub, although it almost looks more like a quadcopter than a drone at this point. And while I mess around with the coding, I want to go ahead and batch up some construction items, just to sort of overlap. Certain things take a while longer than others. I think magnets take a while to make, and I think LEDs take a long time. I should make a bunch of LEDs while I'm here. Alright, so we got that cranking away. Time to take a bath. Don't have my electrolyzer yet to go ahead and crack water into hydrogen and oxygen. I don't have that because I don't have a crafter to consume it. I don't have a crafter because I don't have gold. I don't have gold because it's way deep in the ocean somewhere, which I don't know where. Alright, so I'm going to crank these up. You can actually do a manual configuration and increase the speed of the pivots. And for this scenario, I think probably for any scenario with a attach prop to them or engines to them or anything else, you want a quick reaction time. So I typed in 100. I didn't know what the max value was, but obviously the max speed is rotation speed is 2, and which I assume is 2 rotations per second, and the acceleration it cranks up to 10, whatever that happens to be. And we'll crank that up. All right. Now, one thing I don't do is muck around with the configuration of the actual prop, except to change the twist. And the reason I'm doing that is that I don't want the props on each side of the vessel here to spin in the opposite direction to sort of counteract any centrifugal force that may occur, or torque pulling it from one side to the other. So, which means that these on the right, I need to invert whatever speed I provide to them that I use for the left. Yeah, I was thinking there's no way to determine which way the it's pushing with a prop. So what we got the one inverted wrong or something like that, and it's pushing the wrong direction. But then I realized it has a thrust value. So in theory, if I invert the ones on the right and then I invert the speed, positive to negative, negative to positive, the left and right should have the same thrust. The thrust should be positive or maybe negative. I'm not sure which way the thrust is going. I guess we negative since we are pushing in the opposite direction. For an airplane, you would tend to typically pull over the housing. I don't actually bother with the looking at the thrust, but that probably would be useful too. All right, let's do some coding here. We're already in scaled up UI from the previous episode. I create a program. Create a file. Now the difference between a program and a file, if you create a program like foo, then the actual file name would be foo.main.exe. If you create a file, then it's whatever name you give it. And you have to be explicit, I guess, with the XC, maybe not. Now, main XC is special. That's the one the computer will initially load and run. The computer, you see that rendering on the computer screen, that's sort of a built-in main.exe. And so if you just created a general program, then what it will do, the computer will do when it boots up, it will render, say, here's a program, and gives you a list up to 4 programs you can select. So if you want to go ahead and pick one program out of a selection, you can. Not really sure how useful that scenario is, but in my case, I just replaced the main.xc, so there's no extra code running on it, and I basically have full control. All right, so what I'm doing here is I'm defining the pilot seat channels and typing these out manually. My touch typing is a little rusty, so actually kind of good practice here. In future episodes, I'll just copy paste this right in, so we don't have to watch me try to type here. So this information comes from the wiki. So in the wiki under components, if you look up pilot seat, you'll see all the channels in it. And so now the key mapping, if you look at the, you go to F1 input, all the mapping is listed there. I actually had a little test tool that I wrote that it's actually in the Steam Workshop, that it would render the output for all the various outputs of the pilot seat. So I kind of like double check by hitting all the keys and see what they do. Now these are the default. They can be rebinded to something else. I think for now I'm using the defaults here. And for now, I'm also not using a controller. There's actually, I have a bug outstanding. One of the part of the controller doesn't function correctly. So I'm waiting for that to get fixed before I switch over to using controller. And there's also some bugs related to using joysticks, which are filed. The thrust is interesting. So okay, so we have, and you can map these any way you want to. So we got backward, forward, left and right. Left and right is really more of you slide to the left and right. But typically in like on a car vehicle, I use that for steering because the keys are really there. So in the same thing, I'm going to use that for pivoting, steering, which is actually a yaw. And there's actually a specific yaw option, but I'd rather not use, left arrow, right arrow for steering. Now with a controller, I think just be easier, use the controller, set that up, but we're not using the controller. All right, so we have all listed out. We have thrust. Thrust is kind of, I think thrust will work better with actually with a joystick, which has a thrust axis on it. Axis 4, I think, is the thrust one, and you map that to the get thrust, and then you can set your thrust and set it to some value, halfway, whatever, and go with that. So it does seem that to control a vehicle, it seemed like you're going to have different code for different types of devices. So they'll be similar, there'll be overlaps obviously, but I think there's differences that you'll have there. And there's no way to actually query the hardware because you could have multiple hardware devices plugged in at one time. So I guess maybe a selection, you boot up and the computer will say, preferred input, keyboard, controller, or joystick, and you click one and it can configure itself based on what you plan to use. That'd be a far more complex piece of coding. Right. And so as I did for the pilot seat, I also add the propeller channel and the small pivot channel. The pivot's called a small pivot, so that would indicate the possibility of a larger pivot in the future. All right. So I'm going to write a little quote-unquote debug function. This is a render various internal state to the computer screen, since we have it right here. And that's why we use the full computer versus the mini computer in the vehicle, because it's useful for various information you want to throw up there. The other option is using a dashboard, which is pretty sophisticated. You can put a dashboard up there and make it transparent and then have text displayed on it. And so you kind of see through the terrain and do some interesting things with that. That's a bit more complicated, so I'm not going to bother at this point. Now, part of the process of me handwriting this stuff out like this is I need to practice the coding to really just kind of lock in the language, programming language. So what I found historically is when learning a new programming language is that you read the stuff and you sit down and have a blank stare and say, what do I do now? What do I type? Look at the manual again, write a little bit, and then look at the manual, go back and forth, back and forth, back and forth. And start picking up additional features. Accidentally hit escape. So what I'm doing here is I'm just going to do it probably the most verbose way of doing it. And for example, I could put the props names in a list, and then just say a comma delimited list, and then just go here and enumerate that and put the speeds in an array, because I'm just rendering the data, so I don't really care about the names per se. So then I just loop through, have a simple loop. So it's having 4 explicit lines. It would be like, set up the array, that's 1 line, and then you have a loop through it, and the actual code 3 lines. Well, 4 to 3 lines, but if you had more properties and more stuff, you can put it all in a definition structure, loop through it, and render it, and increment the next line, and all that stuff like that. But I'm not going to do that this time. Just going to be verbose about it and just replicate everything. And I'm just adding. I started at 4/4 just so the text is not jammed up to the corner of the screen there. So I kind of offset a little bit. And then we know the screen is black because we blanked it out. And then we write some text over it. Now that screen does not auto wipe. So for example, if I remove the blank and just run this, it'll write the same text over itself over and over and over and over. And while the text part would stay the same, the numbers would change, and you end up with these weird blops where the numbers should be out because you're rewriting different numbers on top of each other. Okay, so we have a little debug on console. Well, okay, that's console is really the area below that you print to the console, they call it. So that really should be debug on screen. I'm using the word console as a computer console, which is an older term for it. And that's why I called it a console. Well, in this case, within the game, the console is actually displayed in the bottom. So that should be debug on screen or computer screen. Let me be more explicit. All right, so now we're getting the inputs in the same way. This happens a lot, so I just copy paste this right in there. But I don't. I just copy everything manually, just sort of work on getting used to writing this code. Now I renamed the backward forward into accelerate. I'm going to use this left and right. It really should be, since I'm using it as a yaw, I probably should just call it yaw. And then I'll keep pitch, and then the roll. And then the actual yaw, just not bring that in or call it something else. All right, so now I'm going to change the stuff over here. And I'm going to misspell this one. I'll use the same forward backward versus backward forward. I think. Okay, we got down up, we got pitch, we got roll, we got yaw. And of course, it's telling me I misspelled it. Once again, this is the plus side of typing it out manually. It sort of like reinforces these spelling mistakes and what everything's called and whatnot. Because I got a mistake here. And, oh, yeah. Okay, so far all this should be pretty basic coding type stuff. This is not an advanced code class or code video. We'll start with the basics. So we define various things, and you could just hard code the numbers if you can remember what get pitch number is. Type the number in. I'm not that clever. So this coding is very similar to actually writing a game. For example, the inputs are pulled. So if you wrote your own game, in Python or C# or C++ or whatever language you want to write it in, like one of those basic, how to write a basic game, you'll have this game loop, which is the tick here. And the game loop runs X amount of time per second. If you need to perform physics that depend on time, you would look at the time of the previous tick and the time of this tick and compute the delta, and so you know how far to move things in the world. You pull the inputs, what keyboards are being pushed, if a mouse is being clicked, all that, where the mouse is at. Then you pull that data in, then you do some calculations, and then you render to the screen, and you do it again over and over and over and over. And so this is like a mini game within the main game, effectively. So basically, look at Archean as effectively a physics engine that allows you to write things to run inside of it. And obviously, there's a lot of stuff on the Steam Workshop. There's some really powerful type of examples out there, code-wise and build-wise, available. All right, so now we're doing something useful. So we're doing the output. So we read the inputs. For now, we just sort of save the acceleration. We're going to do something with that later on. Now remember how we inverted the right side props. So that's why we put a negative. So internally, speed is speed. Speed goes in one direction. And then we map it to the prop at the last minute. So internally, forward is forward. And then, okay, so I'm right now pushing on the key. And oh no, I'm looking at why my debug information is not being rendered, because I didn't call it. That should be if not in the seat. So the other thing I want to do is, if I'm not in the seat, I want to kill acceleration, so we don't have the thing flying off. All right. So, and as is in the wiki, if PF using is 0, where no one's in the seat. If it's 1 or higher, it's you're in the seat. And if it's a 1, that means you have the token option in the seat disabled. So you need to select the token option. Now it's by default turns on. If you have an old build, it would be off. But for new builds, it defaults on. And what that token is for, that's token if you want to communicate with your HUD. A HUD is a graphical that goes on the screen itself. It's local to the client only. So the token is a unique value that is per session, and it uses that so the HUD, you can communicate between code on the vehicle and the HUD itself. I actually have a separate video about that. It's an older video, and we're not going to do that, at least not for now. All right, so we're not in the seat. Just kill everything. All the inputs, just zero them all out. Yeah, input smoothing is interesting. I'm going to use it, but I don't know if I'm a big fan of it, because what happens if you push like a key like W, then you get like a value for backward forward, and if you hold it, it will slowly go up. But when you let go, it slowly goes down. It can take a few seconds for it to go back down to 0 again. So if you're zipping along and take your hand off the key, you're still getting acceleration. You're still, getting that feedback, and it takes a while for it to zero out. So if you have everything going, you jump out of your seat, and you keep bringing that acceleration in, then you keep going. If that wasn't turned on, the minute I left, didn't touch a key, they all turned to 0. So me leaving the seat doesn't make a difference. If I leave the seat, I'm not touching any keys, obviously, and they'll all be 0 anyway. So it's only needed if I have the smooth control on. And currently, there's no way to query if that's turned on or not on the seat. I actually filed a suggestion to be able to pull that information from the seat itself. All right, so we got our props, and the props stop moving. I'm hitting W, and I want the prop to move, and I'm looking at the prop, and nothing happens. Okay, so what happened here is I'm using a data bridge. Because of data bridge, the prop is not accessible to the router. Although the name of the prop is not accessible to the router. So I have to go through and name the bridge. So once I name the bridge, the router can find it, will send data to that bridge, and the bridge will then forward it to the prop. So at this point, the prop name, the name on the prop doesn't matter, because it just sends data to that, I think. It must be, because you only have one name on the data bridge. Which means that if you put a data junction on the other side of that bridge and had multiple devices, they all get the same command. You could, okay, now we got spinning. All right. See, I should have, and those negatives were correct because we're spinning it opposite direction, because we have the actual blades inverted from the other side. What I should be displaying is thrust, and if I did thrust, they all should be the same. So that was, and as stated before, I typically will voice over these videos after I record it, so I can sort of critique myself and look at what I did and go, oh, well, yeah, I probably could have done that a little better. Well, I can always do something better. All right, so, and of course, you gotta be sit down. I'm just testing to get out of the seat, and did they stop? Okay, you got props going, and now you notice we're starting to move. So we started going forward, and yeah, and so that could be set internally from the computer. I'm doing it manually right now. And so I could have a switch next to the computer there and toggle the switch, and the switch will enable or disable the anchor from my comfort of my seat. Or if you use a dashboard, you can have a toggle switch on there too. So this is the primitive way of doing things. All right, so we were able to turn our props on, and we were able to go forward, and we were able to go backwards. And interesting that this thing will literally slide. With enough power, you don't need wheels, really. You can just make a big sled. And these props are not optimized. If I make the props bigger, and if I moved them up, made them bigger, they would provide a lot more power. Make a ground-based airboat or air sled. And that's useful because when I test the turning, I can actually test the turning on the ground here and actually force it to turn left or right before I take a dive into the water. The problem, you hit the water, you start floating around and flipping around and doing weird things like that. And so it's easier to do all this here. If you want to work on the bottom, you can sort of artificially lift it by sort of inserting blocks in it, or just initially just build it up in the air. You know, build initial frame, anchor the frame, and then once you anchor the frame, you can just build on top of the frame and have it kind of float there. So the way I'm going to do the left-right yaw here, or I guess that's redundant saying left-right the yaw, is when I want to go to the right, what I want to do is boost the acceleration on the left engines and reduce it on the right engines. And then when we yaw to the left, we do the opposite, increase the power on the right side and reduce the ones on the left side. And that should provide a spinning effect. If I remember to put the... So I'm putting something temporary in here just so I can... and this doesn't work because I blanked the screen in the debug area. So I'll make a couple bugs here. So I take that one out. Okay, put one in here. And now the knit and the first tick happen on the same game cycle. So if you grab the clock during the knit and the clock during the tick, they're the same. So there's no delay effectively between the knit and the first tick. All right, so here I am playing with the key, and I'm just getting, you know, -1, 0, or 1. I'm going, wait a minute, I should be getting, and now smooth controls on. All right, so turn that on, because I don't want steering like all or nothing. I want more gradual steering. Okay, so here we go. And you see how it kind of delays. I hit it and then kind of wait for it to delay to come down a little bit. I guess it's possible in the code to make that curve a little faster. Here I'm playing around the props. So what should happen is, okay, what should happen after I add some code is I should be able to watch the props speed differences. So I should see one side going faster or slower than the other side. Now, left and right is quite a bit of oomph. So I need to dampen that down a little bit. Now, I have not configured the props. So they're just a default, you know, radius and number of blades and blade side and all that. All I did was, did I increase anything? I forget. No, I think I just flipped it over on the one. And you know, if they're larger, they work better. If you get to a certain size, they will not work in the water at all. And if they're small enough, they won't work in the air at all. So, and these are just they sort of work both in air and water, sort of a compromise. So I don't get optimal performance for either on land or in the water. Okay, so I'm kind of playing around. All right, so I've got to make sure that works. Interesting. So the props don't. So the prop thing here is measuring the rotation. They sort of like have this drifting. They kind of drift in the wind there, if there's any wind. All right, so let's put this. I really don't need that blank there because when the first tick happens, we'll end up blanking it anyway, so that's kind of redundant code there. All right, so we're going to apply the yaw, input into the system. And right now we're just going to sort of just say we're just going to put a fixed value. Whatever we get, we're just going to apply it, and then we're going to see what happens. Now you notice I have a spelling mistake right there on the two RRs. Now, technically, I can pull that from the console. I'm just pull that from the seat since it's the same value and not have to pass it directly in. Let's stick it down here. Okay, so we got, now when I do left right, you notice that prop FR is not behaving as expected. But if you look at the rear ones are behaving as expected. And I'm looking at the code. What did I do wrong? Okay. Figured it out and fixed that spelling issue, and I also noticed the props were spinning pretty darn fast, so let's slow that down a little bit. If I'm in the water, I don't want to be slamming this thing left and right too quickly. Okay, so it looks like we have expected values on the props now. It turns out building this up a lot more complicated than I imagined. I thought it'd be simple, throw 4 props on it, do a couple things, pop in the water, glide like an underwater airplane. And yeah, a little different. So we'll pop that off. And let's check this out. The K option is really nice. So I can kind of zoom back and see what's going on. Going backwards. So it also solved the problem of how I'm going to get this thing in the water. I'll just power up and slide it right into the water. I see it slightly turning, but it we don't have the oomph to really, not at 10%. We don't have the oomph to make the turn. Well, I saw it moving slightly, so let's crank that up. I guess it would be there is a way to detect if you're in the water or not. You can use the I think it's the density. It gives you the composition of the atmosphere. And then on land, it's like 2% H2O, but if you're in the water, it's 100% H2O. So put that sensor like on the bottom somewhere, and you hit the water, you know you're in the water. Okay, so now we're able to rotate this a little easier. Frankly, I think it'd be kind of interesting to purposely build a sled, air sled. I don't think I've seen any of those yet. So this is it. This is the first Archean air sled ever made. And until I see video proof then I'm wrong. I will go with that claim. All right, I'm going to put some formatting in here. It's pretty reasonable, powerful formatting, so I don't have those really long numbers in there. Okay, it's a little easy to read. Yeah, I should have used thrust for those. Future builds, future builds. All right, so we're going to end it here. I don't want the video getting too long. And so we got some progress done. We built a air sled that allegedly will go into the water. And we did some initial testing, wrote some code, you rendered some crap on the computer. And until next time, see ya.